to digress switching. Now next, this line goes to the our CPU UT01. Always 1.8 voltage, right? It means in this line you will get always logic high, always voltage, right? But when you connect the charger, this line connected with the ground internally, so logic high become logic low, right? So power IC sense the. Hello everyone, how are you all? Hope all are you good. Welcome back to the Schematic education in another video. In last video we discussed about the PP-USB 5.0 line in iPhone circuits, how this line work, how U2 IC work, how the MOSFETs in this line, all about the charging section, or you can say this line, how this line connect to the U2 IC and the charging IC, main Tigris IC. Now today we discuss about the charging IC, iPhone charging IC, how this IC work, what are the requirements, what are the fundamentals, what are the controlling panels, how the charging IC output creates, all these features, how you solve any fault, charging related fault in iPhones. If you learn this video, you will automatically easy to learn update models like X 11 series, 12 series, 13 series, 14 series, right? So watch this video with careful. And most of the people vote for the MOSFET video, but on the second, most people want the charging IC, vote for the charging IC related video. But in comment section, most people says they need first the charging IC. So I will make this video for you first, how charging IC work in a iPhone, right? How to solve charging IC related video. Later on, next video, we will discuss about MOSFETs. What are the MOSFETs? How MOSFET works? How to test MOSFETs? The MOSFETs used in mobile phones, cell phones, laptops and other devices. How to test? What are the fundamentals in a unique way, right? And thank you so much for your support. In last video, I made a request to everyone, all of you. And I got lot of comments and reply for that request. Mostly people said from now they watching every video in a YouTube directly, not by downloading them. And I appreciate it because I saw the results. Last video, improvement 30% on watch times. Watch time 30% improve on the regular videos. On the other hand, the other videos, right? I hope you get my point, what I'm saying to you, right? So keep supporting us, this channel. Those people who still watching these videos or these type of the videos by downloading them, please watch the videos directly from the YouTube. I request again, if you consider me as a teacher, as a master, as a sir, mentor, coach, whatever you say in your language, a guru, and you feel that you learn something from me as a teacher, on the other hand, you give me something and give me this, support this channel. It's not my channel, it's your channel. Because if this channel grow, I bring good content for you always on the update videos. Because right now, I'm not giving you even 10% of the knowledge in a phone repairing, in Android phone repairing, in iPhone repairing, or laptop phone or laptop repairing. The most of the knowledge left, I will share with you 100% knowledge. So help us to grow this channel, right? It's benefits for you and other technicians like you. I hope you get my point, right? So support this channel. And one thing more, if you have a no data issue, I mean to say, if you have a good data pack or Wi-Fi in your house, in your nearby, in your shop, right? Please play the videos. If you watch or not, play the videos in a loop. Watch every video twice, thrice, right? So the algorithm sense and boost this channel in your country. If you really want to learn, post this channel. So I think you all are bored with my long lectures. So thank you so much for the support. Keep support us. Now we will start the video how the charging IC work in an iPhone. Now after the long lecture, you might be feeling bored for my lecture. Right, now let's start the video. iPhone charging circuit, or you can say iPhone charging IC. How does charging IC work? So first of all, what are the problem you face in a charging section? First, not charging, right? The most common problem, right, in a mobile phone, or you can say cell phone. When you connect the charger, it does not consume any ampere if you have a iSense charger, or you can say ampere meter, right? When you connect a charger, no consumption of any ampere. It takes no ampere. Also, does not show the charging symbol or any voice, connectivity voice, right? This is called not charging, right? Now, second thing of fake charging. When you connect the charger in iPhones, right? In this fault, when you connect the charger, charging connectivity symbol shows in your screen, right? But does not consume any ampere in iSense charger, or you can say ampere meter. In a normal charger, you see when you connect the charger, a symbol show connecting charger also with the noise or connecting noise, right? But there is a no consumption. It means battery still does not charge. Battery is still the same. It does not charge, right? So it's called fake charging. It means charger connected, you know, the symbol will show on your display, right? Charging connectivity, but does not store the battery. Now third, slow charging. In this fault, when you connect the charger, the battery charger connected noise, charging connected, you will see the charging symbol, also the connecting noise, plus it takes some ampere or low ampere, or you can say the battery should be charged in a suppose 1 hour for full storage full, but it takes 7 to 8 hours, sometime 12 hours for charging full. It's called slow charging. You might be seeing this type of faults. Now next fault, battery stuck on 1%. If you remove the battery or replace with the new battery, but this fault had a same condition. Battery does not show the real storage in it. It shows only a 1%. Or sometime when you connect the charger, your phone turning on, but when you remove the charger, battery stuck on 1%, or your phone switch off automatically, right? Now next, one side connected charging. Now iPhone cable connected both side, right? You know that connectivity from the cable are both side working. But in this fault, you will see when you connect the charger, it's connected only on one side. When you connected to the other side, it does not charge or not connect. You replace the new cable with a new cable, but fault remains same. It's called one side connected charging. So in this video, we will talk about all these faults, how to remove these faults. Now before going to the charging IC, first we revise a little bit about charging line, PP USB VBUS 5.0 line, right? Remember in last video we discussed about this line, how this line connected to charging port to the charging IC, also with the MOSFET connecting to the U2 IC, right? So we discuss about little bit about this line. I will show you with the circuit how this line work in a small introduction. So who is new here, who did not see the previous video, they will know also this line, how this line work. Also you will revise again so you can understand charging IC in a much better way, right? In this video I will talk about a little advanced level diagnosis. So if you face any problem which is mentioned for the charging related issue, then first should you try a normal tasks, basic tasks, right? I mean say basic things. First clean the charging port, obviously change the charging flex. If you doubt, replace with the new battery. So these all are the basic things. In this section we discuss about only on motherboard repair, right? Motherboard related problems, how to trace fault, charging related, right? How to diagnose, right? These type faults step by step. So let's start the video. So first going to the motherboards. So in the layout we copy just again first charging connector and paste in schematics diagrams. Alright, just next and next again. So just zoom it, and this was the charging connector. I will show you in a main motherboard also, so you can repair easily. So this was the charging connector, charging flex connected here, right? This side you will see ground, right? This point you can say ground, and this point you will see a main charging connected point. So in this point you will get a 5 volt when you put the charging flex on this connector, right? Through charging port 5 volt from motherboard through this charging connector goes through motherboard, right? Now just copy and diagram, and this was the main line PP USB. Just copy it, and next just clear this thing. Now these are the multiple caps. I will explain already in a previous video. If you do not watch, then watch the previous video first, later on this video, so you will better understand. Now next, now TP, right? TP 2501. Now where is this TP? I will already show you again. I will tell you this TP. You will get this TP 5 volt. After connecting the charging flex, connecting the charger without battery connecting, you will get 5 volt here, right? Now next, so these pays for the voltages. Which line will you get how much voltage? You might be ever confused how much voltage on this line. So you go through this page and check out how much voltage on this line whenever you confuse. This is a good thing by iPhone schematics, right? Now next, now again next, now this line goes to the charging IC, right? VBUS line. Next, this line also connected to the MOSFET, right? Through MOSFET, another line connected to the U2 IC. right? Now this line goes back to the same IC. Now I will show you with a diagram. I will explain to you with a diagram. Now you will see this diagram. First, when you connect the charger, there is a 5 volt. You can get 5 volt on this TP, right? If you did not get 5 volt here on this TP, suppose, right, you already replace the charging flex, or I mean to say do the basic things, clean the charging port or replace the charging flex. So if it did not get here 5 volt, so you can check the diode value, right? Sometime this line short, full short or half short. For this, you will check on the multimeter with the reverse bias, black probe on this TP, and disconnect the battery, and red probe somewhere connecting with the ground like this, right? So you will get 350 to 550 diode value on a reverse bias, black probe on the TP, red probe on the ground. Now turn it to the forward bias. Forward bias means red probe on the TP and black probe on the ground. Now this side you will see OL, right? According to your multimeter or some multimeter, right? So that means this line will be okay. No problem here, right? Problem in your charging connector. Soldered it properly, right? On the other hand, forward bias, if you get same reading, suppose 350 to 600, that means this line is equal to half short. So first you clear the half shorting on this line. How? I'm already explained in a previous videos. Just go and check out the videos, right? Maybe sometime any capacitor on this line, right, component short, or sometime U2 IC, sometime charging IC, any reason. We will talk about later on this reason. First we will diagnose this fault, right? If this line is short and half short, just clear the first short, half short or full short, whatever. Your problem will be resolved automatically, right? How do you check? I'm already told you. Now after that, you will see a transistor, you will see a MOSFET, right? Now MOSFET drain connected with the 5 volt line and gate connected with the ground pin with the 10K resistance. Now source connected with the U2 IC, right? Now 5 volt here you will see on this point. Now same 5 volt you will get on this point, any capacitor on this there, right? How do you check? Just go to the motherboard and in schematics find this transistor. I will show you again. Now next find the transistor. Now this resistor transistor Q02, right? Sorry, Q1701. Just copy this and paste in layout. Next, near the charging IC, in component section, you can see this transistor. Now you will surprise, most of the cases I'm solving with a phone come to me with another shop. Most of the time this resistance, this MOSFET is not missing. This MOSFET is not there, missing. So how can you replace or if you had same MOSFET, then you will replace it. Otherwise, you will connect drain point to source point, a jumper. Your problem resolved. Right? I hope you get my point. I am explaining little faster because I'm already explained a deep explanation in a previous video. If you do not watch the previous video, how this line work, what are the MOSFET, how this MOSFET work, just go and check out the previous video. Right? Now let's move on to the another line for the diagram. Now this line goes to the U2 IC. Now diagram. Now the source connecting to the U2 IC. After the U2 IC, here giving to the a signal to the charging IC, to the enable the charging IC. On this signal you will get a clock like this. Right? You can see here a test point. Right? On this test point, you will see with the DSO a clock signal. If clock signal is there, that means your U2 IC is completely okay. Right? And same line goes connecting to the multiple balls we know in a charging IC called VUSB. Right? After you will get a PMID cap, first voltage from the charging IC output, 5 volt on a PMID cap. Right? There is a multiple cap, so each and every capacitor you will get 5 volt. Now if you get this 5 volt on here, that means this whole line from charging connector to the charging IC, whole line connect are okay. It does not any problem. This whole line, not this line. Right? Clear? Hope you get my point. If you get 5 volt here, if you did not get 5 volt here, then work on this line. On this capacitor, first check last capacitor here connected to this line for 5 volt. If you get 5 volt here, then problem in maybe charging IC, or this line not connected properly and on internally to the charging IC. Maybe this line open to the motherboard for some reason like waterlogging or drop down. Right? So you can change the charging IC, or first remove the charging IC and check the line with the multimeter continuity mode. Right? Both probe here, one probe here, and connect it for the beep. If you will get a noise, beep noise, that means this line connected your charging IC voltage. Right? If you get 5 volt here on a PMID, that means this whole line, you can say this PPUSB voltage 5 volt get enter properly to the charging IC. Confirmation basically. Now next, after the PMID, right, the next you will see a boot cap. Right? A capacitor connected in a series. This capacitor connected both sides to the IC. Now when you check this capacitor with the multimeter on a diode mode, you will see the different diode value in the both side. Right? A difference diode value. Most of the capacitor you will see one side you get a diode value. Right? Other side this capacitor most of the time connected with the ground pin. These capacitor connected on a parallel line. Right? But this capacitor connected in a series, both sides you will see connected with the IC or with the different volts. Right? One side you will get 350 to 500 diode value. Other side you will get plus diode value. Suppose if you get here 350, then you will get here 500. Right? According to your multimeter. If this capacitor, when you measure this capacitor, if this capacitor shows same value on both sides, right? Then this capacitor was damaged. You just replace this capacitor with this same value. I will show you in a motherboard fastly. Now look at the IC in schematics. This was the cap. First pin connected with the G5 and other side connected with the other A4, B4, D4 and C4. This was the boot cap C1402, right? Both side you get different value. Also you get one side you get 3.7 to 4 volt, right? At other side you get 6 volt to 8 volt, right? Through this capacitor and a coil, IC switching and create high ampere. Now I will show you where is this capacitor. I'm already explained about this capacitor in a previous video, but I will show you again, right? So
layout.
Next, near the BPQ baseband IC component, and this was the baseband IC. So I think this cap, this was the boot cap. This cap is the boot cap, and this is the main switching coil with connected with the boost cap. Other side goes to the VCC, like a VPH, goes to the other section. It is a always voltage, main voltage to your phone, like VPH, right? Now get back to the right. Now next, now I will tell you about this coil. I will show you just this coil. On this line goes to the VCC as a voltage collector to detector, main always voltage, like a VPH or V system. In MediaTek you will see a V system. In Qualcomm, in Android phones you call VPH. In iPhone you can call VCC. This was the main voltage. This voltage goes to the audio section, network section, light, graphic, Wi-Fi, Bluetooth, most of the sections, right? So this was the main voltage. If you don't know about this, go and check out the previous videos of mine. Each and every videos I will explain this about this, how this line work. So I'm already explained this concept in a previous video, so I will tell you a little faster in this video. So another line comes from this line and goes back to the charging IC. This line called VDD in iPhone, VDD main, right? In this line you will get 3.7 to 4.2 voltage, right? Now same line you will see in an Android called VPH or V system. Same concept. After next, another line with a, in this line another line comes from VCC line, and in this line you will see a MOSFET, right? This MOSFET controlled by the charging IC. After another line comes from the charging IC. This line called VBAT, right? I will show you in a schematics also, but first you understand. And this line also connected to this MOSFET. Now first you understood this concept. After I will tell you the next. When you connect the charger, your VCC, this voltage generated by or made by the charging power, right? That means your phone run on a charging power. Clear? Also the same time through this MOSFET, charging IC control this MOSFET, charging IC enabled to this MOSFET, and same time through charging voltage goes to the battery line. This line goes to the battery connector. I will show you, right? Like this line goes connected to the battery connector. When you connect the charger creates the VCC. Also the same time charge the battery. Clear? Hope you get my point. But when you remove the charging IC, deactivate this MOSFET. In this MOSFET, another diode inbuilt. So this MOSFET is off. So through charging battery voltage, VCC generate through this voltage. Through this voltage, battery voltage. It means your phone run on a battery power. Right? When you connect the charger, your phone run on a charging power. Your VCC created by the charger power. Okay? Right? Or same time, your battery charged by the charger power. When you disconnect the charger, charging IC sense and deactivate this MOSFET. After the battery power goes through this MOSFET and your phone run on a, and you can also call your VCC run on a battery power. I hope you will get my point. If you have any doubt, just comment this video. I will tell you again in your reply. Now this line called VBAT in Android. I will show you in schematics. I'm already explained these in a last video, how this concept, right, about charging IC. So get back to the one and diagrams. So boot cap. After this was the coil, and this line goes to the VCC main, and a line comes back from this called VDD main, right? Now in this line you will see a MOSFET connected with the VCC main and AP VBAT VCC, right? I will tell you. Now this line connected to the MOSFET, also the MOS gate connected to the charging IC, like this. The gate, first VCC connect with this MOSFET. The MOSFET gate pin connected to the charging IC, right? After charging IC, release one line called PP VBAT VCC, right? PP VBAT. This MOSFET also connected to this line. So source connected to the PP VCC main and drain connected to the PPP VBAT VCC. How this function work, I'm already told you. Just click this line, and where is this line going? Now next, now this line also connected to the battery connector. You will see PP VBAT VCC. In this line you will get 3 capacitors. Same like as Android working. I hope in your mind this line clear how this line work. Now next, what are the lines in charging IC? In this video, the main video start from here, right? So this was the R charging IC. Now which line I will already tell you. PMID clear, VBUS clear, right? Also the boot cap, buck switching and VDD main. This whole line clear and bad, right? The remaining line, first now we will tell about VBAT sense, right? How this line work. For this we going to the PP VBAT VCC. Now next, now this line goes to the battery connector, right? Same line, I've already told you. Now this line connected to the both side. You will see pin number 1 and pin number 7. PP VBAT VCC. Here the positive point, right? In this line you will see another line called charger VBAT sense. First I will show you in a bitmap. So this was the bitmap. So this was our battery connector. This pin, right, and this pin connected PP, VBAT, VCC. So you can see these both points are the same, positive, right? Now in this line, another line connected PP, VBAT. Just a second. Now in this line also connected charger VBAT sense. Now in this line you will get 3 capacitor here and 3 capacitor here. It means 6 capacitor. On this line PP, VBAT, VCC, this is the main battery connector line. So in this line you will get 350 to 550 diode value, right? When you connect the battery on the TP or in this capacitor, you will get the battery voltage, whatever the battery voltage, right? When you connect the charger through this line, your phone charges the battery. Clear? I hope you get my point. Now click this line, charger VBAT sense. Now this line, next. Now this line goes to the charging IC, pin number E1, right? Charger pin number E1, BAT sense, charger VBAT sense, right? Now in Android you will see the ID pin, BAT ID. Through BAT ID pin, your PM or PMI, PMI or CPU knows the battery connected or not, right? But in this model in iPhone, through this line battery sense, a positive line goes back to the same charging IC. Through this line charging IC knows battery connect or not, right? Through this line your charging IC sense the battery connected or not. Clear? I hope you get my point. It's an easy one. In this line you will see no component, just a pad, a difference pad. On this pad you will get this, right? I hope you get my point. Now another active diode. Already I will tell you about this line. This line operate the gate on this MOSFET. This MOSFET, or in Android you will see inbuilt in the IC, right? Now next, HDQ host and HDQ gauge. First we understand HDQ gauge, F2. Now click this line called battery switching, and next. Now this line goes to the battery connector and connected to the pin number 2, also 4, 3 and 5. Battery switching connected. In this line you will see inductor, I mean to say coil, right? Also a capacitor, right? Now go to the Borneo. Yes, right. Now in a main bitmap you will see these 4 pins, right? These 4 pins connected each other. In Android you will see the 2 lines. There are 2 lines mostly, one for the BAT thermal and one for the BAT ID, right? Connecting, right? Just like these 2 pins. Just a second. These 2 pins connecting each other for the BAT ID in Android, right? And these 2 pins connecting for thermal. I hope you get my point. But in this iPhone, these all pins are same, right? And connecting to the HDQ gauge with the charging IC. Now get back to the diagram and see where is this line going. Just next, now this line goes back to the battery connector. So same. Now HDQ gauge pin number F2. First, I will draw this line, bad sense, and after that draw this line HDQ gauge, and after I will explain to you. Now in last video you will see this circuit, right? How this circuit work. Now next, how the charging IC, next lines, right? Now another line from the battery connector, positive, goes to the charging IC. This line called VBAT sense, bad sense, right? I'm already explained to you in a schematic. Through this line, your charging IC sense battery connected or not, right? In this line you will get 3.7 to 4.2 voltage. Now another line, HDQ gauge. These 4 lines on a battery connector are same to these 4 lines, right? These 4 lines are same. From this line, from this point, a line connected to the charging IC called HDQ gauge. Now what is the gauge? I've already explained it in a video from gauge IC. In Android, you will see a VBAT sense resistor connected to the positive point, or sometime in phones, some phones in a negative on a battery connector. Through this resistance to another line goes to the PMI, or right, for sensing the battery current, how much battery charge at a time, or how much current requirement for the charging full. Clear? Also in some phones another IC, separate IC installed called gauge. In some phones this IC, in a PMI IC, charging IC installed. In some phones there are a separate IC called gauge. Now gauge IC sense battery connect or not. Also what are the battery status, how much battery charge at a time, or how much requirement to charge battery full. From analog to digital convert, and this information given to the CPU, right? Remember, if you don't know about how gauge IC work, I'm explaining all and each and every data in this video. See this video and your all doubt will be clear in a few minutes, right? In a deep detail. Now in this IC a gauge section installed, right? This VBAT sense pin also connecting in a gauge section, right? Now this pin called HDQ VBAT HDQ gauge, right? Through this pin, charging IC sense how much charging, or you can say charge or current at a time in a battery, or how much requirement to charge full. After the charging IC, this data convert to the digital, analog to digital, and give it to the CPU. How? I will show you the next line. The another line from charging IC to the CPU. This line. What is the now? Right? So this line. So this line called, I will explain to you in a schematic. Right? Then this line called HDQ host, AP to Tigris switching. Now next, this line goes to the our CPU UT01, U0201. This is our CPU, right? Next, this line connected between charging IC and the CPU. In this line, you will do not get any component for testing, right? This line directly goes to the CPU. Through this line, CPU sense this violet color line. First, CPU sense the battery to this red color line. After, battery gauge this green color line, battery, how much battery charge or battery status or how much requirement. After, convert to the digital form and through this line given to the CPU, right? HDQ host. This line name called HDQ host. Excuse me. I hope you get my point, and you will understand clearly whatever I teach you. If you have any doubt, and just comment this video. So I hope you're clear about this line and this line, HDQ gauge and HDQ host. Now let's get back to the schematics. HDQ host, HDQ gauge. Clear? These both are lines. How this both are lines working? First, through HDQ gauge, this charging IC senses the battery status. After, through G1 line, HDQ host, in this line, the charging IC give it all information, or you can say CPU take all information to the charging IC, the battery status information. Now, I hope in your mind all this clear, how this line works. Now next, A3, B3, D3 and C3 P ground, positive ground. Most of the videos I'm says the ground pin are important. Now there are two type of grounds. One, the common ground, right? And second, the important ground. Suppose a common ground called a capacitor in a parallel line connected with the ground pin. When you remove the ground, there is no effect because this was the common ground line. But another line, there was a separate ground for the positive. This ground are importance. If this ground did not work or missing, your phone had a problem, right? I will talk about on this later in another video. Let's see how this other functions work. Now call VBUS detection. Now this line test a ground. So next F1 VBUS detection. When this line you will see a 68.1K resistance, right? VBUS detection. If you want, I will show you these line in a main motherboard, but I hope you get my point, what I'm saying to you, how to check this line. In this line, you will see one resistance, 68.1K, called VBUS detection. Now, where is this line going? Next, now this line goes to the same CPU U0201 layout. I will show you so you can understand. There is U0201. I hope, right? On diagram, and next again. Now same. So this line connected between charging IC to the CPU. In this line you will get one resistance. Now first we draw, after I will explain to you. Now next, a line connected to the CPU. On this line you will see a resistance, 68.1K resistance. From this line CPU sense charging detect or not. I mean to say VBUS detection. When you connect the charger through this line, CPU sense charging connecting or not. Suppose your phone is turning off when you connect the charger. How the CPU know to show the display a battery icon through this line? VBUS detection, right? So this resistance is also important, right? So if this line was damaged, your charging not detected, right? In off condition, also in on condition, right? Get my point? When you connect the charger through this line, CPU sense charging connect or not. When you connect the charger, how the CPU know the charging connect or not? Charging IC activate from other. Also, the charging IC enable. I mean to say CPU control the charging IC through other line, I2C lines. So CPU knows also when charging connected or not, in off condition or on condition through this line. VBUS detection. On this line you will get a one resistance. I hope in your mind this line clear. Now get back to the schematic again. Now what is the next line? G2 INT, right? Call interrupt. In this line you will see, now this line goes to the PMU, right? Main power controller IC. Also in this line you will see 100k resistance, also the capacitor on 1.8 voltage, always voltage through LDO, right? Always voltage. First I will draw and I will explain to you how this line work. Now just a second. Now this through charging IC, a line connected between charging IC and power IC. This blue color line, I'm not made a capacitor here, just only a resistance, 100k resistance, right? In this resistance you will get 1.8 voltage, right? Through power IC, right? Clear, right? Through power IC. Now in this line CPU will know the charging connect or not, VBUS charging detection line. So how the power IC will know the charging connect or no, not, right? So in this line you will get always 1.8 voltage, right? It means in this line you will get always logic high, always voltage, right? But when you connect the charger, this line connected with the ground internally, so logic high become logic low, right? So power IC sense the charging connect, or you can say charger connect. You get confused? I will tell you again. This line, in this line you will get a one resistance, also a one capacitor, 100k resistance, right? Now the other side of the resistance connected same to the power IC, also the charging IC. Clear, right? In this line you will get 1.8 voltage always. So in this line, in this point, in a power IC 1.8 volt without connecting charger. When you connect the charger through a MOSFET, internal the charging IC ground this pin for some time, then power IC sense 1.8 voltage become a 0, logic high to logic low, right? And power IC sense the charging connected. Clear? I hope you get my point. Now where was this resistance? I will show you in a motherboard also. Just copy this resistance 1403 and paste in layout. Now zoom this one near the NAND, and so this one, second one. This one under the red line, this capacitor, right? 100K capacitor. One side connected to the power IC, also other side connected to the power IC and charging IC. Here, through this resistance, or you can say through this line, power IC sense charging connect or not. Clear? Now get back to the schematic for the next line. Right? Clear how interrupt line work? Now next, VBUS OVP off. I'm already told you in a previous line. This line comes from the TriStar IC to enable the charging IC. In this line, you will get on a TP, you will get a data clock like this. This VBUS OVP off. Clear? Now E3 system alive. I will explain you this line, but first the SDSCL. These are I2C lines. These are connected to the CPU. Clear? Right? For the through CPU, through this line, right? CPU get all information about the charging IC. What are the charging IC status? How charging IC work, or any command given by this SDA and SCL. I will draw first. Now two lines from charging IC and the CPU connected between the CPU and the charging IC. CPU control charging IC through these I2C lines, green and purple color lines, right? Or given any command. If your charging IC had any problem, shorting, or any kind of problem, CPU deactivate through this line. Also take all information, how charging IC work, right? These are the I2C lines, right? CPU command take information through this line, right? Now next, a power IC, next line through power IC, another line goes to the charging IC. Now which line is this? Just go to the schematic. Now clear? Now I will tell you this line, system alive, E3. PP 1 volt 8 SD RAM. I'm already shown you in a diagram through power IC of one line. Goes to the charging IC. This line, right? In this line you will get 1.8 volt. Now how this line work? Now in this line you will get 1.8 volt. When your phone turning off in off condition, when you connect the charger in iPhone, you will see when you connect the charger, when your battery charge, your phone automatically turning on without pressing the on off switch, right? That's why this line called system alive. Suppose if your battery fully drained, when your battery on a position to 3.7 volt to 3.8 volt in between, suppose of 1%, your phone turning on without pressing the power on off button. In Android, when your phone turning off, the battery become 1 to 100, but your phone switch off. Phone turns on. When your phone turn on, when you press the power on off switch. Clear? But in iPhones, When your battery 0, your phone turning off. When you connect the charger, it's turned on automatically, right, through this pin. I hope you get my point. Clear? Now get back to the schematic for the next line. On this side, PMID clear, VBUS clear, SDSL clear, system array clear, VBUS OVP clear, INT clear, detection clear, HDD cage clear, host clear, active diode line clear, FlatSense, VAT, puck, boot, this LDO line, G4. Right, in this line you will see a capacitor, 2 capacitor. Right, I will not draw this line because these lines are simple. I will tell you. In charging IC, there is another MOSFET. Through this MOSFET, these 2 capacitors connected for the filtration to the excess voltage, for smooth working to the charging IC. These are also, all these capacitors also are important, right? So, but this capacitor working for the filtration only. This line not going anywhere, right? So that's why I'm not making this line. In this line you will get 5 volt. Clear? On this capacitor. If you did not get 5 volt here, that means your IC internally faulty. Clear? Now where is this capacitor? Just copy anyone and paste in layout. Now next, now this capacitor just above the MOSFET. I will show you in the main motherboard. This capacitor. Right? This one, a small capacitor. Right? We'll get a 4 volt ground. Not 4 volt, almost a 5 volt. 4 volt to 5 volt. Clear? Now, I will explain to you all these lines, how the charging IC work in iPhones. Hope you will learn something new in this video, how the charging IC work. Each and every line with the proper detail. If you have any doubt, just comment this video. If you like this video, also comment and share. And remember my message when the video starts. Please do not watch without downloading. Watch the video on YouTube and share this video with the other technicians on your country. For boost this channel, I'm bring always a good content for you, a paid content in a free for you. I'm giving you time, knowledge, so you give me this. If you want learning more, then subscribe it, like it, share it. Love you all. Will right. See you in the next video. Thank you. Love you all. Take care. Charging connect.